Hello friends, this video is brought to you by www.moateaching.com.
We know that comparison among the individual items are best shown by means of graph. The representation then becomes easier to understand than the actual data. We shall study the following graphical representations in this class: bar graph, histograms of uniform width and varying widths, and frequency polygon. We start with bar graphs, which are the simplest of all graphs. Recall that bar graph is a pictorial representation of data in which usually bars of uniform width are drawn with equal spacing between them on one of the axes, say it is x-axis, depicting the variable. The value of the variable are shown on the other axis, that will be y-axis, and the height of the bar depends on the value of the variable. Let us take an example and move further with the bar graphs. In a particular section of class 9th, 40 students were asked about the month of their birth, and the following graph was prepared for the data so obtained. Here we can see that given graph is a bar graph. It has bars of equal width and there is equal spacing between them on x-axis. Also, the x-axis is depicting month of the birth, which is the variable. On the y-axis is the value of the variable, that is the number of students. The height of the bar depicts the value of the variable, that is the number of the students who were born in January are 3. Number of students born in February in that particular section of class 9th are 4, and so on. In the question, we are asked, observe the bar graph given above and answer the following. First is, how many students were born in the month of November? From the graph, we move to month of November and see how many students were born. We can see that 4 students were born in the month of November. Second part of the question is, in which month were the maximum number of students born? So let us see which of the bars is of maximum height. We can see this particular bar is of maximum height. So that means in this particular month, that is August, maximum number of students were born. Let us read the question. A family with a monthly income of rupees 20,000 had planned the following expenditure per month under various heads. Draw a bar graph for the data. Note in the second column, 4 in front of grocery means rupees 4,000. 5 in front of rent means rupees 5,000. Here, heads are the variables. So let us take them on the x-axis. And the expenditure in 1000 rupees is the value of the variable, so we will take it on the y-axis. We represent the expenditure value on the vertical axis. Since the maximum expenditure is rupees 5,000, we can choose the scale as 1 unit equal to rupees 1000. Now to represent our first head, that is grocery, we draw a rectangular bar with width equal to 1 unit and height equal to 4 units. Similarly, let us represent the other heads, keeping a gap of 1 unit in between the consecutive bars. In this way, the bar graph for the given table is drawn. Let us now study histogram. It is a form of representation like the bar graph, but it is used for continuous class intervals. For instance, consider the following frequency distribution table, which represents the weight of 36 students of a class. We can see it is a continuous class interval 30.5 to 35.5, 35.5 to 40.5, and so on. Let us now represent this data graphically. We start by drawing horizontal and vertical axes, and also we introduce a kink in the horizontal axis since the first class interval is starting from 30.5 and not 0. We show it on the graph by marking a kink or a break on the axis. Next, we represent number of students, or basically the frequency, on the vertical axis on a suitable scale. Since the maximum frequency in the table is 15, we need to choose the scale to accommodate this frequency, and we represent the weights on the horizontal axis on a suitable scale. We can choose the scale as 1 cm equal to 5 kg. Also, since the first class interval is starting from 30.5 and not 0, we show it on the graph by using a kink. We now start drawing rectangular bars of width equal to the class size and the length equal to the frequency of the corresponding class interval. For example, the rectangle for the class interval 30.5 to 35.5 will be of width 1 cm and length 9 units. In this way, we obtain the graph. Observe that since there are no gaps in between the consecutive rectangles, the resultant graph appears like a solid figure. This is called a histogram, which is a graphical representation of a grouped frequency distribution with continuous classes. Also, in a histogram, the width of the bar plays a significant role in its construction as it varies with the class interval. However, in this case, since the width of each rectangle are equal, the length of the rectangle are proportional to the frequencies. We will now look at another example of drawing an histogram where the width of the bar will vary according to the class size.